And now we have exercise 1.3 question 2D. Notice that 2D is somewhat different from the previous two questions because notice that we only seem to have one inequality but have no fear. What we can do is we can separate this inequality into two parts. How do we do that? First we can take 3x minus 5 is lesser than 31. So I write it down. I create my first inequality and I take this part and I write 31 is less than 2x minus 7. The rest of the steps remain the same in this case, so we shall solve the one on the left first. We get 3x is lesser than 36 and finally x is lesser than 12. Similarly, for the one on the right hand side, we have negative 2x is lesser than negative 38 and finally x is larger than 19. Now, as we have done before, what we can do now is this: we represent both of these inequalities on a number line. So 12 will come here, 19 will come here. X is lesser than 12, this one, so we write x is lesser than 12. Okay, and we also have x is greater than 19. So down here I have x is greater than 19. Then now I shall attempt to find where do these two inequalities overlap. If you notice, in this case they do not overlap. Them not overlapping simply means this: there is no inequality that will satisfy both this one and this one. Hence, if there is no inequality that satisfies both of them, what happens is that there is no solution. And we are done with question 2D. Now we move on to question 3. Okay, question 3 is to find the integer values that will satisfy these inequalities, where we get 5x minus 1 over 8 is greater than negative 2 and is lesser than or equals to 2. Okay, similar to what we just did in question 2D, we first separate it out into two inequalities. Alright, so now we have these two inequalities ready. Now I solve the one on the left. Notice that there is a denominator of 8 in this case. What I can do is multiply both sides of my inequality by 8. Multiplying by a positive number does not change the direction of the inequality. So I get 5x. Negative 16 is lesser than 5x minus 1. I shall collect my x terms on the left hand side and all the other numbers on the right hand side, like this. Then dividing by negative 5, in this case because I have divided by a negative number, the direction of my inequality changes to x is greater than negative 3. Similarly, for the inequality on my right hand side, multiplying both sides by positive 8, I get this. I simplify. 5x is lesser than or equals to 17. Finally, I get, dividing both sides by positive 5, x is lesser than or equals to 3 and 2/5. So you notice now I actually have these two inequalities, same as what we have done so far. We just represent our answers, okay, or rather our inequalities on a number line. Okay, let's locate. Negative 3 should be on the left, 3 and 2/5 will be on the right, 0 will be somewhere here, no necessity to draw 0. Okay, x is greater than negative 3 and x is lesser than or equals to 3 and 2/5. Once again, we look for the region where they intersect. Quite obviously, the region is down here. So what I do, I draw an inequality to represent this region, and I have this. Once again, we have to translate this back into an inequality. So I say that x is greater than negative 3 and is lesser than or equals to 3 and 2/5. Okay, is our question done? No, our question is not done. Why is it not done? Is it because I've forgotten to draw these two strokes here? Nope. If you read the question, it's because they say that we are to list the integer values. Quick recap, what are integers? Integers are whole numbers that can be positive or negative. Okay, for example, negative 4, negative 2, those are negative integers. Negative 5, 7, perhaps 15, these are positive integers. Okay, 0, is it an integer or not? Yes, it is an integer. Okay, 0 is neither positive nor negative. It's a special case. It's called the zero integer. So now we have to list values of x which satisfies this inequality that we have just solved. So x cannot be negative 3. So the next one will be negative 2, negative 1, 0. Okay, 0 integer, 1, 2, 3. Can we choose 4? No, we can't, because x is lesser than or equals to 3 and 2/5. And hence, that is the conclusion of my question, where we have the listing of the integer values.